Here we have a word problem, and in this case it's a problem that represents either exponential growth or exponential decay. In this problem, what we want to do is just write the equation that models this word problem. We don't have to solve it for any particular value, we just have to come up with an equation. You can probably guess that since this is an equation modeling exponential growth or decay, there's going to be an exponent involved somewhere. Let's read the problem and see what we've got. It says, in 2008, a car was purchased for $17,000. Each year since, the resale value has decreased by 27%. Let t be the number of years since 2008. Let y be the value of the car in dollars. Write an exponential function showing the relationship between y and t. Okay, so y represents the value of the car. That's what we're wanting to put on the left-hand side of the equation. And we'll have some equation here that represents that value of the car. First, let's just think about what the car is worth after 1 year. So you paid $17,000 for it, and then it decreases by 27%. So one way to get that would be to take 0.27 and multiply it by 17,000 and then subtract that. But another way would be to subtract the 27 from 100. We'd get 73. So we can say the car is worth 73%. So for that first year, we could just take 17,000 and multiply it by 0.73. That would give us the value of the car after 1 year. If we wanted to find the value of the car after 2 years, we could take this thing that we just calculated and take 73% of that. So just multiply it by 0.73 again. And then after 3 years, we could do the same thing, take 0.73 of that. And in fact, however many years you have, that's how many times you're going to multiply it by 0.73. And this pattern should ring a bell when we're dealing with exponents. The exponent tells how many times you multiply something by itself. So in this case, if we wanted to find the value of the car after 3 years, we could say 17,000 times 0.73 to the third power. Or we could write a general formula here where we put in, instead of the 3 for 3 years, we put in the t for the number of years. In that case, we'd get this formula, y equals 17,000 times 0.73 to the t power. And now we can use this formula to say what's the value of the car after 1 year, or after 7 years, or after 17 years. So that is how to write an equation that models exponential growth or decay.